Hello, statistics students, and welcome back. This is still chapter 5. We're on to example number 3, and we're talking about cows, Angus cows in this case. The mean weight of an Angus steer is 1,152 pounds. Suppose the weights of all such animals can be described by a normal model. Okay, so it says a normal model with a standard deviation of 84 pounds. So here we have a normal model being used with 1152 as the mean, right? And 84 as the standard deviation. So this 1152 is the mu, and then we have a sigma of 84. Okay, so question A is, or part A, how many standard deviations from the mean would a steer weighing 1,000 pounds be? All right, so as you should have guessed by now, you need to state somewhere in the problem your method for calculating how many standard deviations above the mean something is, which of course is a z-score. So I think I'll place it over here. That is x minus mu, or standard deviation, or my sigma. So here I have the z-score of a 1,000-pound cow would be 1,000 minus the 1152 divided by 84. Now, a 1,000-pound cow is below average, so we expect this z-score to be negative. We should expect it to be negative, and it comes out to be negative 1.81. Okay, which means that this steer is 1.81 standard deviations below the mean weight for Angus steers. Okay. Here's a couple things to note. You have to say 1.81 standard deviations. Below, I get through the negative sign, and we say the mean weight for Angus steers just to give it some extra context. We probably don't have to put this in here. Okay, we could say below the mean. Okay, and probably get away with it. All right, so that's 1,000 pound. And then it says which would be more unusual, the 1,000-pound steer, which we just found up above, right? We just found that one up above, or one that weighs 1,250. Okay, well, I need to create a z-score then for the 1,250 steer. So I do 1,000, oh, I'm sorry, it's not 1,000 anymore. It's 1,250 minus 1152. We still are assuming that they're pulling from the same type of Angus steers, divided by the 84. This one weighs more, right? Weighs more than average, so we expect this to be positive, and it comes out to be positive 1.17. Okay. Now this is great, right? We could interpret it. It doesn't say to interpret the z-score. We can for practice. This steer is 1.17 standard deviations above the mean weight. Okay. Again, it doesn't say that we have to do that, but just for practice, we can do it here. It's not too bad. And then it says which one would be more unusual. Okay. So when we're thinking more unusual, we're thinking further from zero. Okay. Further from zero. Well, 1.81 is further away from zero. This negative 1.81. It's farther away from zero than 1.17. So the 1,000-pound steer is more unusual because it is more standard deviations away from the mean weight. Okay. You can rationalize it and say that its z-score is further from zero. Okay, but you have to be just really careful. All right, the easiest way to do it is just keep it in standard deviations, and then talk about it being more standard deviations away from the mean. You can't say more standard deviations away from 0. Okay, and then that should give you 4 credit there. That is just the only 2 parts to that question. We have another example number 4 coming up in the next video.